So when we're doing all of our problems, and I mean seriously, from here on out, I would say probably at least 75% of the problems are going to require that you go through these problem steps. Okay? And if you follow these steps, some things are going to change. Like what are your assumptions and conditions? Those might change. Your formula, your name, your describe, those things might change. But the fact that you're going to do those should be the same for any problem that I ask you to do, a confidence interval, or what we're going to be doing next, which is called a test. Okay? These guys don't go away. All right. So, first off, don't worry about pacing or anything. I'm not holding my breath for too many more snow days. So, we had flex time kind of built into the schedule. So, basically, we just pushed everything back a day because you guys missed last Thursday, yeah. So don't worry about that. Your quiz is not today. Your quiz is going to be next class, which would be Wednesday. So just letting you know about that. Today we're going to be finishing up confidence intervals for proportions. And I did have a couple of folks who said they were working through their homework and were able to get all but a couple questions. We're going to address those today. It's actually a pretty simple kind of patch. So what we're dealing with margin of error is we're basically saying, okay, I have made this observation. This is what I think is true because this is what I saw to happen. And what we're going to do is we're going to take that and expand that to what I think is always going to be true. And for confidence intervals, for margin of errors, you've got to balance this idea of being certain. Like, I'm 100% certain that the temperature tomorrow will be between negative 100 and 250 degrees. Yay! I'm going to be right. I'll bet on it. $1 million. Hey, because if it's outside of that, the world's probably over and I don't need my money anyway. I don't have $1 million. You're not going to get it anyway. Okay? That's certainty. Being certain isn't always good enough. You really want to be precise. I want to know what's going to happen. I want to know how often this cold medicine should work. And so that's what we have to do with this. So basically what we talk about when we do confidence intervals, the most common number that we use is 95%. 95%, if you remember from your empirical rule, we have the 68, 95, 99.7. Remember that? 95 was how many standard deviations? Dos. So that's why a lot of times you'll just see the p-hat plus or minus 2 standard errors. That's just because it's a nice, easy approximation. The actual z-score for 95 is actually 1.96, which is a number you guys will probably memorize just as well as I did. Okay. So when we talk about our confidence interval, we start with that p-hat right here. And that plus or minus, that is your margin of error. Okay? So if I were to ask you to find the margin of error, it's just this portion. The confidence interval is centered at your observed going up and down that margin of error. And almost all of our confidence intervals, like if you want to break it down even further, is whatever your estimate is, whatever comes from your statistic, your sample, plus or minus the margin of error. And today we're really focusing on that idea of the margin of error because it allows us to kind of calculate different things. Lets you kind of figure out before you get started, how big of a sample do I need? Or if I want to make sure that I am meeting legal requirements, how big of a margin of error can I have? How does that affect what my plans are? Don't worry too much about writing all of these things down because you already have the general formula for confidence interval. You have probably the slightly more specific where it was estimate or statistic plus or minus critical value, standard deviation, or standard error. You already have that. Okay? So that's all that we really need to worry about with this. The thing that you do need to note, this is very important, if you want to be more confident, if you want to be more sure in your prediction or in your observation, then you're going to need to have a larger margin of error. And that is because when we're doing our formula, our estimate, not going to change. Our center's not going to change. Standard error, not going to change. What will change is our critical value, and that's tied to your z-score. If you want a bigger margin of error, you're going to need a bigger z-score. You want a bigger z-score, you're going to need a bigger confidence level. Okay? Here we go. So those values, that z-star type thing, those critical values, that is what I just talked about, the fact that it comes like the 2, which is used a lot. We don't even really use it that much because, frankly, why not just skip straight to z-scores? Why do I have all this up here? We've talked about critical values, didn't we? We talked about critical values, yeah. Okay, so we talked about using inverse norm and basically your standard error. I don't even know why I've got that up there. Okay, we did this. And we said that when you're finding your z-score, basically you're saying, okay, if I want a 90% confidence interval, we said that we take 0.5, because that's the middle, plus half of that. So 0.5 plus half of 90 is 0.45. That's 95. That takes me up to a 95%. And that's where I would use my inverse z to find. And that would give me that number, 1.645. It's another number you're going to use a lot of. And we did that. That's a whole bunch of repeat. Okay, here we go. Actual question. Go ahead and read through that. This is in your original packet of notes. So you have this problem written down. And we're going to try to work through this using that stuff that I asked you to write down at the very, very beginning. So that stuff that I gave you, that warm-up, by the way, you're looking at Chapter 18, Day 2, not in the printed out PowerPoint notes, the ones that I'd given you before. It should be basically the last page and the one I gave you before. The amount of paper flipping is astonishing. I'm surprised you don't have breezes going around the room. Flip, flop, anonymous. Less and less of a tornado as people, I think, get closer and closer to it. Should either be pretty much the last or the second to the last page in your notes. Pretty darn close to that. All right. So what was the very first thing that I had up there that you had to do for all problems? Identify what you're measuring. So for this guy here, what is it that I'm measuring? So what? A little bit more specific even than that. That's it. It's the proportion of red beads. That's all we need. So I'm going to start by saying P is equal to the proportion of red beads. Okay? You always start by writing down what it is that you're talking about. Sorry. Okay. What was the second step? Identify the pieces. So what are the pieces that I have from this? N. What is N? So what would that be? So I would say N is, and one more time, what was N? 251. What other pieces do I have? P hat. What was P hat? Just give me the fraction. And you guys are always going to need to show the fraction. Decimal's option. Math enter, enter. And it should be just 107 over 251, which means what would Q hat be? 144 over 251. We need those because oftentimes some of that is required when I am checking my assumptions and conditions. And it just so happens that what is your next step? Check assumptions and conditions. Those are needed for them. Okay, hang on a second. So why don't you guys go through checking your assumptions and conditions? What assumptions and conditions do you need to check? How do you write this down? Yep, calculators are good things. Lord knows that's not happening in my own head. Goodness gracious. And by the way, this here, it says AP style for a reason. All it says is use your interval. It says calculate and interpret, and then use your interval to comment on this claim. This is a good free response question. Very little instructions, though. So you have to understand what it is it's asking you to do. It's going to be one of the hardest things. So what are my assumptions and conditions? First one, independence. Do we have, well, in order to do independence, we need to check randomization. Do we have that? Yes, it says SRS. You might not see the word random written out, but that stands for simple random sample. What else do we need? Small enough. So we need to check the 10% rule. What number? 251? 251 has to be less than 10% of all the beats. We don't know that right now. Okay? I'm not sure, but I'm going to write that down. And then there's one more. Success, failure. So this is how I write mine down. Told random sample. I hope it's less than 10%. NP hat, that's just the top number. NQ hat, that's just the top number. Both of those are greater than 10. Greater than or equal to. Really, you shouldn't have a case where it's equal to. It's very rarely, if ever, going to happen. After that, what do I do? Describe the model being used. That means what kind of distribution do we have? So in this case, we're going to have X follows shape. One more time. Normal. No. For now it is. Okay. Normal model centered at with a spread of, how do I calculate spread? P hat Q hat over N. So that's 107 over 251, 144 over 251, all over 251. And I'm going to go ahead and calculate that before I get too far ahead of myself. Square root. Oops, I hit all the numbers. So I got that to be 0.0312. Because I'm going to use that, and I can either keep writing that over and over again, which doesn't sound like fun to me because it's a lot of numbers, or I could just write that. But I have to show where that number comes from. So we've identified what we're talking about, our bits and pieces, our assumptions and conditions, our model. Now what? Name the test. What we're doing right now, we only have one to choose from. And that is that we are going to do a 1 proportion z interval. And while we're at it, let's just go ahead and throw in what percent. What percent am I using for confidence? 90. Yes. Absolutely. I just don't have much more line. What comes after that? Calculate your confidence interval, but even before that, you have to show the formula. Now, when you show the formula, you can either do it like that, and then say, we already have P hat listed. I already have my standard error listed. So what's all I need to show? My Z star. How do I calculate Z star? Not inverse tan. That's a little different. Inverse norm. I'm going to do 0.5 plus 0.9 over 2. And that's going to be 1.64. That is okay. When I'm talking about show your formula, you can either do it this way, and that right there covers everything I need because there's P hat, there is Z star, there's the standard error. I can find everything, everything's labeled. Or if you would rather, you're more than welcome to say, and I'm just going to write this as or, 107 over 251 plus or minus 1.64 times 0.0312. You can do that either way. I don't care. But it is part of the grading requirements that I must be able to see what formula you used and what each of those pieces were. This satisfies that. This, with all the pieces, satisfies that. I don't care which one you do. Okay? Then what do? Do the calculations. Find your confidence interval. I find it easiest. Okay, so I find it easiest by saying over 251. I do the minus first because I'm going to give me my smaller number. And I'm going to find that's my Z star times my standard error. And I got 0.375. And that's my lower number. Then I'm just going to do second enter to get all that jazz back. And I'm going to change my minus to a plus. 0.478. Okay? What's the step after that? Interpret. Interpret what? My results in context. So this says, this is my results. And it even said in your instructions, it said, calculate, done, and interpret. A 90% confidence interval. Generally, you're going to do the interval unless they ask for the level. So how do I interpret this? I have a sentence that goes with this. Based on our sample. We are 90% confident, and you are more than welcome to abbreviate confident. I don't know how it gets spelled after F. I probably do, but I don't even guess it. We're 90% confident that what? The true proportion of red beads. Do not say population parameter. Go up to your parameter and write down what that was. Okay? The true proportion of red beads, and I really should say in the container. Okay? What's next for my interval interpretation? Is between, and yes, you are welcome to abbreviate between. And then, yeah, and you can do 37.5, or you can write it as a decimal. It says proportion, so I'm going to leave it in terms of proportion. If you want to do percent, you want to use the word percent here, you can do percents there, but try to make sure they match. I don't care which one it is, just make sure they match. You okay with that? Then it says at the very end, use your interval to comment on the claim. What was the claim? Teacher claimed 50%. What does my interval say? Okay, so the teacher said 50. My interval says this. What do you think that means? Not necessarily the claim is wrong, but what we're going to say is we have evidence. Remember, we're never going to prove anything here. We just have evidence. The teacher's claim is wrong. And then you simply have to say why. So why? Right. Because 0.5 is not in the interval. Okay. So it's kind of misleading that the question itself was kind of short and sweet. And they would give you basically one full piece of paper with that little question across the top. Sometimes they'd give you 2 full pieces of paper. And all of that is the way you have to show. Okay? Any questions there? This isn't necessarily even, yes, it's about what is your interval. But in statistics, a large majority of what we're getting to here is showing why that's your answer. All right. So if you were looking at the homework, it did a little bit of playing around with the confidence intervals. So we need to understand that for a confidence interval itself, there are actually relatively few things that you can change, that you have any control over. So if we look at this, I cannot control the population parameter. I can't control what I'm trying to measure. I'm not going to say find the proportion of red beads and, well, okay, I want to change it now. Now I'm going to talk about the proportion of people who like bacon. I thought I was kind of trying to be random there. I think I worked. Random. Bacon can't be random? Humans can't be random? Okay, sure. I know. Population proportion, parameter, whether it's mean or proportion, you can't change that. And that's also, I can't change. What's really trying to say here is I can't change what's true. If I were to look and I were to say, okay, the proportion of M&Ms in a container that are blue, the Mars company has a set ratio. I don't have control over what that ratio is. I don't physically know it. But they do follow a general algorithm that says, okay, this much of this much of that. Okay? I cannot control the population standard deviation, so how much the spread is in the population. I can't change anything about the population. That is what's true. I can control two things. The confidence level. Do I want to be 90%, 95, 100? How confident do I want to be? And I have control over my own sample size. Those are the only two things I can change. I can change N, and I can change confidence level. How does the confidence level show up in my formula? Z star. Those are the only two things I can change. Okay? So what's going to happen is we're going to ask, what can I do to make my confidence interval wider, narrower? What sample size do I have to have a confidence level of this exact size? I can do those, but the only things I can change are your confidence level and your sample size. All right, so when we choose a sample size, this is often a really big part of statistics. They will say you need to be accurate within. Like when you're talking about the weather, they are going to say we have a 3-degree guarantee. Ever heard that kind of a comment before? We're going to be right within 3 degrees. Like whatever I tell you, the actual thing is going to be within 3 degrees of that. Or if you look at snow predictions, they give you this range. And they believe they're accurate to within a half an inch or an inch or whatever it is. And what we can do is I can set you that requirement to begin with. You have to get your stopping distance to within 10 feet. You have to get your candy within 2 degrees of this temperature, otherwise your sugar is going to burn. Okay? I can do that. And it all centers around this formula. Remember, my margin of error may change a little bit here and there. My formula I use for it, but the general idea is going to be the same thing. It's going to be your critical value times your standard error. Because we don't know what's true about the population, we're using our p hat. So this is the formula that I'm going to be using. Now again, I have control over Z star. I can determine my confidence level. I have control over N. So I can change my sample size. Those two things can change my overall margin of error. Now, this is the one little key piece for those of you who are looking at the homework going, I can do all but. This is the key piece for that. If I'm asking you to find a needed sample size, but they don't give you P, what we have to do is we have to kind of go for the worst case scenario. And so what we use is we use 0.5. Because what that will do is that will give me the largest sample that I would actually need. You guys remember, maybe you've done it in calculus, maybe you did it before, but you know how when you have a parabola, you can find the maximum or the minimum? Those values. That is going to occur that you maximize this equation when P is 0.5, which means Q is 0.5. So, if I am asking you, this is very important, if I am not telling you P and Q, if I'm asking you to find sample size needed, not given, sample size needed, you can use 0.5 as your worst case scenario. Now, if I gave you a problem and I ask you, what sample size did they use, then your P and Q are going to be what your P and Q were. Does that make sense? Okay, but if you do not have a P and Q, use 0.5. And then what we're going to do is we're going to solve the formula for n. This is probably the most difficult arithmetic you are going to do all year. The most difficult equation solving, because that's an equation I want to solve for n. Now, I don't know about you, but I'm not very good at memorizing. I can remember that formula because that's kind of built into everything that I'm doing. And some people choose to solve that once and memorize what the formula is to find n. But one thing that I do know is that the easiest way to deal with that is to try to solve for n before you put any variables in. Because once you put numbers in, it actually becomes a lot harder to solve. So I want you guys to copy that formula down again. Leave yourself some space. And what we're going to do is we're just going to solve that for n. I want to get the n by itself. To get the n by itself, what would you do? Divide by z star. Then what would you do? Square both sides. Now, at this point in time, n is in the denominator. There are a lot of different things that you can do, but I find that it's easier if what I'm looking for is in the denominator, literally just do the reciprocal of both sides. So I would have z star over the margin of error squared is n over p hat q hat. That's going to make your life a heck of a lot easier to finish solving this. Because that means to finish solving this, it's just really one more step. What do I need to do? Multiply by PQ. So n is going to be p hat q hat times z star over the margin of error squared. Some people choose to memorize that. I never do because my memorization sucks. I really can't memorize things to save my soul. But if you would like to do that, that's perfectly fine. You guys okay with what I did there? If you don't memorize it, the steps to solve it are always going to be the exact same thing. All right? Okay. So here's the type of place where we might see this in a question. Go ahead and read through this again in your notes. Go ahead. There's a lot of words here. Not many of them are actually needed to do the work. In that problem, can you drill down to what it's actually asking me to do here? What's it asking me to do? Find the sample size needed for what? A 95% confidence level that is accurate within 3%. So what I'm trying to do here is I want to find sample size if I have a 95% confidence level And I want my estimate to be within 0.03. What is that 0.03? That's your margin of error. So I'm just going to write down the things that I have here. I'm going to leave that there. What I have is that I have my margin of error is 0.03. I have my confidence level that I want is 95%. And I want to find N. Those are my goals. So you see how this is your margin of error. If the confidence level is 95%, what can I use that to help me find? Z star. So let's go ahead and do that. And again, this is a number that you will very quickly memorize. So far, so good with that. If you're charging it, make sure it's plugged in the back. Now, P hat and Q hat. I don't know what that is either, though, do I? So worst case scenario, what should I use? Use 0.5. That's going to maximize. If I wanted to maximize this value, I need P hat and Q hat to equal 0.5. So that means what goes into my formula now here is that N will be 0.5 times 0.5 times that 1.96, the whole number, over the margin of error, all of that squared. Is that what you guys got? Now this here, what I'm going to say is very, very, very important. This is one time where we have a set rule. If I'm looking at sample size, you must always round up. If I were to use just 1,067 people, my margin of error is going to be a tiny bit bigger than what I'm looking for. I need to guarantee a margin of error of that, so I always round up. So I'm going to need at least 10,068 customers. Yes, ma'am. Well, in your assumptions and conditions, you have randomization, but then you have 10% and success failure. 10% and success failure both depend upon that number. Okay, so I can't quite check that. This is saying my first step, what would it need to be? But that also means that if I want to be within a 3% margin of error, if you can think about it this way, there has to be more than 10,680 customers. Just as a little side note. So if my manager wants me to be within 3%, and I know that I only have 5,000 regular customers, can I meet that requirement? No, and sometimes that's the case. Sometimes they're going to say, I want you to do this. And you can say, well, that's nice. I can't. It cannot be done. All right, here's a textbook problem, so this is not in your notes. Basically the same thing over and over and over again. Go ahead and do part A. Put your pencils down for a second and look up. For this problem, do you see how it says it's believed that as many as 25% of adults? Do you see that? For that, if they give you something where what we believe is true about the whole proportion or the whole population, use that as your P and your Q. All right? Does that make sense what I'm saying? You only use the 0.5 if they don't give it to you. Or if they're asking like worst case scenario, if that's not true. Okay? So go ahead and go. If you do not put a label on that, there goes half your credit. Okay? Context is that's all statistics is about the context. For B, 318, and for C, 564. Questions on any of those? Yes, ma'am. I just wrote it down like that because a lot of times they use that number. When I'm doing it in my calculator, I'm not rounding at all. Are you okay with that? Yeah, no, I just wrote that down because you're going to, for some reason, they do that. They say that the Z star for 90%, they use the 1.645. I really don't care if you write 1.64, 1.645, or keep going. All right? Yes, ma'am. Nope, you're good. Because, yeah, well, adults, and yeah, I would just leave it at that. As long as you use the word adults, that would be clear enough context for them. Cameron. And that's what you want to be careful about, and that's okay. But if you're wanting to save time, the easiest way to do that is to grab the first problem that you use, like hit enter. Just do it that way. Okay. They're pretty lenient, I will admit, with the grading on this. And it's actually kind of hilarious to look at the grading because what they will literally do is they will say, if you used 1.645, these are the answers they should have had. If they used 1.64, these are the answers that they should have had. If they used the actual value, these are the answers they should have had. If they used the conservative estimate of 0.5, these are the answers they should have had. So literally the graders are given a list of what are acceptable. But the thing that they have to do, and which is usually a really good thing to show just in case you use a different value, show what your decimal is out to at least 1, and show that you are actually rounding up. Is that okay? All right. And what you'll see here is they actually say for a more cautious answer, like if you want to be 100% sure, you can use the 0.5 method, and you can see what that does. What I want to point out here is I want to look at the answers that you had. This one, my margin of error was 0.6. I needed 141. The margin of error here was half of that. To half my margin of error, did my sample size go up or go down? Go up. I wanted a smaller margin of error. My sample size went up. I halved my margin of error. Is this times 2 this? That's it times 4. And if you don't believe me, 564 divided by 141 is 4. So halving the margin of error, I went up to 4 times the sample size. Now, my next question, I want to take if I were to do the exact same thing, if I were to keep my confidence level here at the 90%, but instead of taking a 6% margin of error, if I said my margin of error had to be 2, how do I go from 6 to 2? Divide by 3. To go from 6 to 3, I divided by 2, and my sample size went up by a factor of 4. To go from 6 to 2, I divided by 3. Anybody want to take a guess as to what your sample size would have to go up by? 9, and it is by a square. And the reason why, I'm just going to show you this really quick, and then we can move on. We've got one more problem and then an actual old AP question. My margin of error formula was Z star root PQ over N or P hat Q hat over N, whichever it is that you need to use. If I want half the margin of error, and all I'm going to do is change N. To have this all over 2, do I need to put next to my N? So I'm not going to change the P or the Q. I'm changing the N, and I can only do that by putting a number here. To get a 2 here, what do I need to put here? A 4. Does that make sense? If I wanted to take 1/5 the margin of error and only change the sample size, what number would have to go here? Are you all okay with that? This is one of those common things that they'll do is they will say, if I want to half my margin of error, what do I have to do to my sample size? And they will specify, do not do the interval. Do not calculate. They want you to show it conceptually. That's what they're asking you to do. Understand that N is inside a square root. So any factor that you want to change, you're going to have to square that. All right, this one's going to be a little bit different because we're changing. I can't just say, oh, I'm going to times it by 9. It's 1/3 of the margin of error. This guy, you are going to have to calculate because I'm also changing my confidence level. Go ahead and do that, please. So for this, you should get one more time. 1801 adults or 1801 people. Good. And again, if you wanted to be more conservative, you could have used the estimate of 0.5. Had you done that, you would have needed 2,401 people. Answer. Yep. Yep. The only time that you cannot use the 0.5 is if I'm asking you, what did they use to get this confidence, to get this margin of error? Okay? All right, so you guys are going to need to understand very intimately what the relationship between confidence level, sample size, margin of error, confidence intervals, how those all change. What can I do to make my confidence interval narrower, wider, my margin of error smaller, bigger? What can I change? All right, here is actually a free response question. This is the guy that has the crazy graph on it in your notes. It's got like the Triga diagram on it. We're going to try to get through this. This is the first ever time you have seen a free response question number 6. That's the hardest level. Okay, so we haven't done any number 6s because number 6s typically require us to do some kind of test or interval, which is what we're doing right now. So the free response questions that we've done a couple of 5s, but we've never done a 6. This is a number 6, and number 6 is actually worth more points as well. Okay? Has a higher multiplier. So go ahead and read through this given situation. All right, do you get the gist of what we're talking about here? I have a lot of people whose eyes probably just glazed over at that amount of writing. That's fine. The first question says, come on, why aren't we moving? Let P be the proportion of all United States 12th grade students who would answer the question correctly, correct, and interpret a 99% confidence interval for P. What is this asking me to do? Confidence interval. All right. Let's completely disregard all of that writing. What I'm asking you to do is a confidence interval. To do a confidence interval, what do I need to show first? The what? Even before the pieces, I need to show what I'm talking about. What am I looking for? Correct? So I'm going to start this problem by identifying what it is that I'm talking about. What am I talking about? P is the proportion of students who did what? Who would answer the question correctly. That's my first piece. What comes next? N. Okay? So, what is N? 9,600 students. Do you see that all the way down here? All right. Don't let the question itself overwhelm you is what I'm trying to get at. What else do I have for pieces for this? P hat and Q hat. What was P hat? 0.28. What was Q hat? All right. Not terrible. Oh, one too many zeros. Thank you. That will change things. A little bit different. Okay, what else do I need? Assumptions and conditions. What's my first one I need to write down? And in order to meet the independence, what do I need? Do we have randomization? Yep. So I'm going to say told random sample. What else do I need to check? Less than 10%. So I'm not sure, but I'm going to hope that 9,600 is less than 10% of all what? Of all 12th grade students. And really, that's all they're expecting. You don't need to state without a doubt that it is. I mean, it really is. There's a lot more 9th grade students than 96,000. But you can just say hope. Then what do I need? Success, failure. So I need to physically show 0.28 times 9,600 and what that gives me. What do you get? $2,688. And then I will need the flip side of that. So you can either subtract that from 9,600, or you can do the multiplication again. What do you get? Okay, and both of those numbers are greater than 10, so large enough. This here is my think part of the problem. Although the question does not set out and ask that, if you do not show it, you have lost a large majority of the credit. I also need to tell what my distribution is. What is my distribution going to be? Shape, normal, centered at, and ladies and gentlemen, you have to put that mu. Where is it centered? 0.28. And the standard deviation, you have to someplace, I mean, if you want to go straight to a number here, you can, but someplace you're going to have to show the calculation for it, so that's why I do it here. So I would say 0.28, 0.72, all over 9,600. And while I'm at it, I'm going to calculate that. Because I just think it's easier to write that one number than it is to write the whole thing down again. Then what do I need to do? Before you do that. Right, the one proportion z int. Name your test. We're going to do a one prop z int. And while I'm at it, let's identify the confidence level. What confidence level do I want? So they want to be pretty darn confident. And sometimes people consider this under this is the think, show, do part. Some people think about this next piece as either the show or the do. It doesn't really matter. What would my formula for that be? Times the standard error. So I have the standard error written down. P hat is written down up there. So I just need to make sure that I have my Z star listed. And I'm going to write down what? At least write down 2.58. If you want to write down the formula with every little bit and piece in, because you can type it in the calculator, that's fine. If you want to leave it like that, I'm lazy, I don't want to write it down. That's fine too. So I'm just going to do my p hat. I'm going to do the minus first simply because it's easier when you're writing small to big. I'm going to write my z star times my standard error. And my small number is 0.268. I'm going to do the same thing, but I'm going to change it this time to a plus sign. And I get 0.292. So, think, show, do, and then what? Interpret. So how would I interpret that? Based on our sample, I agree, it sucks to write all this down. You're welcome to abbreviate as much as you want. Okay? Now, each free response question is on a 4-point scale. This whole part here is 2 of those 4 points. Okay? They would have broken it up probably right about in here. Ladies, if you're leaving, just make sure that you know that you have a video you have to watch tonight, and your quiz is next class. Okay? But that's 2 of the points. Okay? And so this is what they're talking about. What they have here, they've gone back and forth. This is an older one. They don't actually ask you to check the 10% condition here as part of the credit. They have gone back to that. The reason why they didn't was because you don't know what the whole population is, so they weren't counting that as part of it. But you can see everything that they expect you to see, all of your answers. And section 1 is scored correct if you identify the correct inference procedure, checks the random, check sample size. Okay? And these are all the notes that they give it. Random sample is given is sufficient. You must include Z, proportion, and interval. Those are words that you must have. Stating the correct formula is sufficient. We haven't done any of that stuff, so I don't want to confuse you to see it. Section 2 is scored if you calculate and interpret the interval correctly. So that's 1 point for each. Okay, go ahead and read through this. Okay, so look at your table. See if you can fill out that table where everything would go. Can you fill in the table? Where would your proportions go? Some of your answers will have K's in them. Not all of them, but some of them will. What do you think? Are you filling it in? Trying? Okay, I'm just going to kind of push us through this last part here. This is what you should have done. So we knew the probability if you were to guess at random. Does it make sense why just guessing at random, you have a 25% chance of guessing correctly? Where did that number come from? There were 4 options. One of them is going to be correct. 3 of them are not. So guesses randomly and answers the questions correctly. It's going to be 0.25 times 1 minus k. And then this is going to be 0.75 times 1 minus k. Because they're saying on this, k represents those who actually know the answer. So since we're talking about the percent of people that don't know the answer, that's 1 minus k. And so what they're saying here for C would be that probability that's up at the top here. And you can write that a couple of different ways. But the probability they answer correctly, so you see here that we're moving in probability rules come together with this. It's not just intervals. And then you see how D says use your interval to interpret. This is what would go into a problem number 6. It doesn't say it up there. I need to put it in. You guys have a video to watch for chapter 19. Pretty sure. We will be quizzing at the beginning of next class. I lied, you don't have a video. The video is for the second day.